now that we've spent a ton of time working with just manipulating rational expressions, we want to talk about how do we solve an equation involving these fractions. So we're going to go through two things. The very first thing we're going to talk about is what is the domain of a rational equation, and then we want to figure out how do we solve these, and we'll do a ton of examples. So first and foremost, the main thing you have to remember when you're dealing with these kind of equation problems is that we can never, ever, ever divide by zero. So when we have a rational equation, we're going to have that variable that appears in the denominator, just like it did in our previous sections. And we need to make sure that we're excluding any numbers that cause zero in the bottom. Because our ultimate goal is we're trying to find values that satisfy this equation, and it could turn out that it could be a problematic number. So we want to get really good at figuring out what values are problematic, what values are okay, and how to check if these things are going to work. So we're going to start by figuring out what the domain of a particular equation is. So we're going to see something like 3 divided by x plus 4 minus 2 over x minus 9 equals 5. And for this specific problem, we also want to state that domain in interval notation. So first and foremost, I have these two factors that appear in the bottom. Both of them involve our variable. So what I want to do is I want to figure out what value is a problem. So I want to set each of these denominators equal to 0. And from there, we just solve our equation as we have been before. For the first one, we subtract 4 from both sides. And that gives us x equals negative 4. For the second one, we add 9 to both sides to get that x equals positive 9. So these two values are both problematic because it will make it so that we have a fraction 3 divided by 0 or 2 divided by 0, and we don't want that. So our domain would be just that. X cannot equal these numbers. They're two problematic numbers for us. Okay? And really, this is all we need to do, but let's get some practice with our interval notation, because it does say to state our answer in that. So we draw our number line. We have two important numbers. These numbers we cannot equal, so they have open circles, but everything else is going to be good. So this first interval to the left starts at negative infinity and goes up to negative 4. We can't equal negative infinity or negative 4, so we get parentheses. The middle interval here starts at negative 4 and goes to 9. And then this last one is 9 to infinity. And remember, we join these with our union. So this would be the domain of this equation. Okay. So now that we have a little bit of familiarity with that, we want to just practice solving an equation. So very first thing you need to do, no matter what, is you have to figure out which values are problematic. Because these variables are in the bottom, I need to know what can my value or my variable not equal. Once you've figured out the problematic numbers, then our goal is really to just wipe your fractions. So solving an equation is going to be way complicated. We want to try to make it something simpler. So best thing we can do, get rid of the fractions. Once we go through and we multiply by some common denominator to wipe everything, we want to solve that resulting equation. So this is going to rely on our factoring techniques. This is going to rely on solving our linear equations. We're going to be building and utilizing a lot of stuff from prior sections. And then afterwards, once you solve that simplified-esque equation, you want to check your solutions. And again, I don't necessarily mean check in that you plug it back in and make sure it works. But you want to make sure that value was not something that was problematic, because that could be an issue. So we really are just going to do a ton of examples. We want to solve the equation. So first and foremost, on every single one of these problems, we want to figure out what are some problematic values. So right here at the get-go, we have x in the bottom. So you're going to set that equal to 0 to find what your problematic number is. So for this particular equation, I cannot let x equal 0 because it would cause 15 divided by 0 in this second piece. So my first step is done. We've gone and we figured out what the issues are. Now, working with this equation, I don't want to try to condense anything or anything like that. What I want to do is multiply the entire equation by something that's going to wipe my fractions. So in this case, the thing we're going to multiply is the least common denominator. And here the first one is x over 1. This is negative 8 over 1. So really our least common denominator is just going to be x. So I want to take this entire equation and I want to multiply it by x. So really we're getting the first piece times x, the second piece times x, the third piece times x. And what ends up happening is in this fraction, we have x divided by x. They cancel each other out. So this leaves us with x squared plus 15 equals negative 8x. Okay. And now we've simplified our problem. I no longer have any fractions, but I do have an equation that I have to solve. So we have to use the techniques from our prior section. We have a second degree equation. There's potentially two solutions. So remember, we always want to get 0 on one side of the equation. And for this particular problem, it's going to be easier to just move this 8x over. So I'm going to go ahead and add this to the other side. And what that gives us is x squared plus 8x plus 15 equals 0. Okay. And then from here, we can go ahead and set up our factoring to get the first term as x squared. We're going to use an x and an x. 15 doesn't have a ton of options. You have 15 and 1. You have 5 and 3. So I'm going to go ahead and try positive 5 and positive 3. And indeed, that gives me plus 3x plus 5x. So we end up with that middle term of 8x. So we found our correct factoring. So now we go ahead and we set each factor equal to 0. So x plus 5 equals 0, x plus 3 equals 0. We solve by isolating our x. So we get one solution over here, x equals negative 5. For this one, we subtract the 3, gives us a second solution of x equals negative 3. So we've solved our resulting equation. Everything seems fine and dandy, but again, I want to check. So looking at both of these solutions, they are not a problematic number. And that is great. That's all we wanted to check. So since neither is problematic, we have two solutions. X can equal negative 5 or it can equal negative 3. Okay. And if you fully wanted to check, you could go ahead and you could plug those values in for x at the very beginning and see you get a true statement. But again, all you're really trying to check is this a problem? Will it cause me to divide by 0? So we will see some examples where that happens, but let's still get more and more practice with this. Okay. For the second problem, we have a little bit more complication because I've got this second fraction that doesn't have a factored denominator. So maybe from these two, you can easily see what the problematic values are. If you can't, you just set them equal to 0. But what I would recommend doing for all these problems is first trying to factor, because that will also help you find what your least common denominator is. So we don't do anything to this first fraction, but the second one has a very special factoring. So to get x squared, you need an x and x. To get minus 4, we do plus 2 and minus 2. Okay. And again, you should see kind of the same factors appearing. You shouldn't have a ton of different factors going on. So you can kind of use that to your advantage while you're setting up the problems. Okay. So really, we have this x minus 2 that appears in two different fractions, and this x plus 2. So our two problematic numbers are we set each of these not equal to 0. So the first one tells us x can't equal 2. And if x plus 2 equals 0, the second problematic number is negative 2. So these two values are off limits for us. X cannot equal either one of them. Right? And now from here, what I want to do is I want to multiply by something for every single piece that will wipe every single one of these fractions simultaneously. So looking at this expression, the least common denominator definitely has to include an x minus 2 because we have it in this fraction and this one. And it also needs to include x plus 2. So if I multiply by this, it will wipe this fraction completely, and it will take care of each of these two pieces as well. But it's going to leave us with some extra. So I want to take this entire equation and I want to multiply it by x plus 2, x minus 2. Okay. So if you need to add some extra steps in, definitely go ahead and multiply by each piece. So we're going to take x plus 2, x minus 2, and times it by this first fraction. Then we've got our plus 21 over x minus 2, x plus 2. And it's going to be multiplied by the common denominator. And then on the right-hand side, we take that fraction and multiply by the common denominator as well. Made that a plus minus 2. There we go. Okay, now we go ahead and we see what cancels out. So for the first one, the x minus 2's cancel. For the second one, everything cancels. And for the third one, just the x plus 2's cancel. So you might be good to just jump to this next step if you feel confident in that. For the 3, you're going to be left with the x plus 2 when you multiply by the common denominator. The 21 is the only thing that survives when we multiply by the LCD. And for the far right fraction, the x plus 2's cancel, so we're just left with 14 times x minus 2. And now again, you see we boil something that's very complicated down to something much simpler. This is a nice linear equation, so we just need to get x's by itself. So first and foremost, we've got to distribute these two numbers. So this gives us 3x plus 6 plus 21 equals 14x minus 28 when we distribute that out. Then we've got to get everything to one side. So I'm going to go ahead and first condense the 6 and 21. That gives us plus 27. And then from here, I'm going to go ahead and move this 28 to the other side first to make those cancel. And that gives us 3x plus 55 equals 14x. And then we move the x to the other side by subtracting it. And those two cancel. And that gives us 55 equals 11x. And what do you know? It works out nicely. When we divide by 11, we get a single solution of x equals 5. And again, going back to this beginning part, 5 is not a problematic number. So this is the single solution that solves this equation. Okay, so let's just keep on trucking. Try a couple more. So we have a ton of fractions again. First and foremost, want to go through and factor them. So definitely make sure you brush up on your factoring if you're not super comfortable, because it's going to be very important for this section. So at this point, hopefully you are confident with that. I'm going to go ahead and just factor. This first one will factor nicely into p plus 2, p plus 1. P squared minus 4 is p minus 2, p plus 2. And then this last one is p minus 2, p plus 1. Okay. And now from here, we look at our problematic numbers. So for this first one, if I plug in -2, it'll give me 0, -1, +2, and then these factors all really repeat. So we have 3 values of p that are an issue. P cannot equal -2, -1, or +2. And now we want to go ahead and we want to multiply this thing by the least common denominator. So I basically just need to see, okay, which factors are appearing. In this particular case, the least common denominator has a p plus 2, a p plus 1, and a p minus 2. So unfortunately for this one, it is a pretty long equation already. So I can't quite go through and write that I'm multiplying each thing by it. So we're going to go ahead and we're just going to see if we do that, which factors are going to cancel and which factors remain. So we'll try to do it, but I'm going to have to erase some stuff to make it fit. So if I take this first one and I times it by that common denominator of p plus 2, p plus 1, p minus 2, the p plus 2's and p plus 1's cancel, and we're just going to be left with p minus 2. So for this first fraction, we're just going to be left with 5 times p minus 2. Now for the second fraction, we have 3 over these two factors. So when we times that by our common denominator, the two things involving minus 2's and plus 2's cancel out. And so we are left with the p plus 1. So we have minus 3 times p plus 1. Okay. And then for this last one, I'll kind of show you just a quick way to think of it. The p minus 2's cancel, the p plus 1's cancel. This last one is 1. The only thing remaining is the p plus 2. Okay. So again, we've simplified our equation now to something that is linear. We go ahead and distribute each of these values. So that's 5p minus 10. Distributing this minus 3 is minus 3p minus 3. And then distributing a 1 does nothing. It's just p plus 2. So condensing our like terms over here, 5p minus 3p gives us 2p. Negative 10 minus 3 is minus 13. And then we still have p plus 2. So isolating the p values, let's go ahead and add 13 to the other side. And that leaves us with 2p on the left and p plus 15 on the right. And last but not least, subtract a p. That leaves us with a single p on the left and 15 on the right. And so we've gone through, we found our resulting answer. 15 is not a problematic number. So this is our solution to this equation. Okay. So I've got 2 more left, and they're both relatively similar to each other because now we're going to start to see where do we run into these issues. Right? So at the very beginning, this fraction's much simpler to deal with, the 1 over x. This one, a little more complicated. So to find my problems, we set each not equal to 0, so x can't equal 0. And then my other denominator can't equal 0. So if you subtract the 1, you get 3x can't equal negative 1. And then divide by 3, negative 1/3 also poses an issue. So these are the two values that my x cannot equal. Right? Now I want to go ahead and I want to weight my fractions. So here our least common denominator definitely needs to have an x to get rid of this fraction. And for these two, I need a 3x plus 1 to get rid of their denominators. So those two factors are in the least common denominator. So we want to take this equation and we want to multiply it by x and 3x plus 1. Since this one's relatively small, I can definitely go ahead and add that extra detail in. So I'm going to take the first equation and times it by these two factors, or first fraction and times it by these two factors. Second fraction times these two factors. And then the third fraction times the two factors in the least common denominator. So on the left-hand side, the 3x plus 1's cancel and leave us with 2x. On the second fraction, the x's cancel and it leaves us with 1 and 3x plus 1. And then last but not least, the 3x plus 1's cancel. We have a negative 6x times an x. Okay. So simplifying this gives us 2x, distribute that 1, this gives us 3x plus 1, and then this one gives us minus 6x squared. So now I have a quadratic. I potentially have two solutions to this. So I need to move all of my terms to one side. Easiest is to just move over that single one to give us 0 is equal to 1x plus 1 minus 6x squared. But I need to set up my factoring for this, so I definitely need to rearrange it. That's minus 6x squared plus x plus 1. And if you want to factor from here, perfectly fine. If you want to take this equation and multiply it by negative 1 to get a positive number out front, perfectly fine. But we can go ahead and just factor as is. We set up our thing to get 6x squared and negative. We can try 3 and 2. So let's try positive 3x, negative 2x. And then to get to positive 1, we really only have one option, positive 1 and positive 1. So let's check our outer and inner. The outer plus 3x minus 2x indeed gives us a single positive x. So we have found our correct factoring. And now to actually solve the equation, we go ahead and we set each of these equal to 0. So for this first one, we have to subtract 1, gives us 3x equals negative 1, divide by 3, and it gives us a solution of x equals negative 1/3. Over here, we can subtract the 1. That's negative 2x is negative 1. Divide by negative 2. And when you have a negative divided by a negative, it turns into a positive. So we have our two solutions. This solution of positive 1/2 was not one of the numbers that we needed to exclude. So this one is good. It is a solution. But for this one over here, this was one of the problematic numbers. So although it solved the resulting equation, it is not a solution to our original equation. So unfortunately for this one, we cannot actually have that. It's not in the domain of the equation. So we often call these solutions extraneous because it's not something that works out. So if you hear that word, that's all it means. It solved the equation, but it doesn't actually work at the beginning. So we'll see more examples of that in later sections as well. All right, so let's just try one more of these. And then again, I can't stress enough to get tons and tons and tons of practice with this, because that's the only way it's going to make these a little bit easier, and you'll start to pick up on doing kind of shortcuts and not having to write every single step out. So for this last one, again, we have a nice couple fractions. So I'm going to go ahead. Unfortunately, that last one is currently not factored, but it luckily does not have a terrible factoring. And I'm going to move that minus sign up top. Factors nicely into z minus 3, z plus 3, which is already the two factors that we had before. So right from the get-go, we have two problematic numbers. We cannot plug in -3 or +3 because that will cause a 0 in these two pieces. Okay. And now we go ahead and we multiply by the least common denominator, which in this case is z minus 3, z plus 3. So I'm going to take this entire equation and multiply through by that. Okay. So at this point, let's try to do the shortcut of not having to write every step out. So for this first fraction, if you were to multiply by that common denominator, the z plus 3's would disappear, and you would just be left with the z minus 3, because those two would cancel out. For the second one, z minus 3 cancels, and you're left with z times z plus 3. And then this one's the nicest. Both of these will cancel out, and so we're just left with the numerator, which is -6. So now we want to solve this simplified equation, but I've got to distribute everything out. When I distribute that z, it gives us z squared plus 3z equals -6. And again, we have a quadratic that we have to solve. So I do need to move everything to one side, but first I'm going to go ahead and condense my z's and rearrange things. So I'm going to put the z squared first. That's plus 4z minus 3 equals -6. Now I'll go ahead and add 6 to both sides. And we want to solve the equation z squared plus 4z plus 3 equals 0. And this one also factors pretty nicely. To get to z squared, we need a z and a z. +3 doesn't have much options, plus 3 and plus 1. Outers plus z plus 3z gives us the 4z. So now that we have it factored, we go ahead and set each factor equal to 0. And maybe now you can see a bit of a problem, because here when we subtract 3, this was the expression we had in the bottom. We get a solution of -3, which is extraneous. So I only end up with a single solution by subtracting the 1. We get z equals -1. So again, get lots and lots and lots of practice with this. If you feel uncomfortable with factoring, make sure you go back over. This whole unit really relies on factoring, so we need to be pretty good at it to be able to continue moving forward.